we're gonna do the very first part of our hierarchy of machines. So we go to downloads, and I assume you have downloaded from the assignment this file, which is provided to you, which has the source for the second lab. So we're gonna extract. So I'm doing this step by step, and you can see that after extracted we have the source2 directory. So we're gonna go into this directory, and the first machine we're gonna run is this machine. Alright, in the instructions here you have this machine. This machine, the first thing it does is gonna suspend another machine, wait until that machine is suspended, and once that happens, alright, it waits for a second, it restarts that machine, again checks that that machine is running, and then waits for a second before it suspends it again. Alright, so I'm going to go step by step with the process. Remember, we had a Catkin workspace from our lab 1. So in source, alright, we don't have the package for the machine yet. In your instructions, if you look at here, the description, it tells you how to build a package. Alright, so I'm going to take that and copy it. And in order to build a package, we have to be inside the source of our workspace. So that creates the package, and so we have turtle suspend resume as a package. We're going to go into it, and although we are providing the package to you here as well, if you look in our code that we provide that this is a package in itself, I'm going to do all the steps again on how we compile LFSMs with ROS. So the first thing to do here is create a directory called machine. Alright, we have it there, go into it, and here in our source code I'm gonna tar the machine. So this is our code, but because we're carrying it, we do this. Alright, then I'm gonna move it into this position. That moves what is, so from downloads and source 2, alright, and then source 2 turtle resume machine turtle resume dot tar, which we just created. We move it here, so we have it there. We extract it, alright, and now just for cleanliness we remove it. I need the set of machines script, the first lab, and in there we have the machine setup script. So now we have it here. So this machine setup script on a machine splits the files appropriately, and it creates a suggested CMake list. But we actually go one level up and look at the real one that was created when we created the package, because of the dependencies on CLFSM and libclfsm. So I'm copying that. I actually go now into the suggested. Let's hope I did the right thing here. Alright. And then the next step is to copy the suggested to override where we just took the dependencies. So now we need to compile this, but we go all the way to the root of our workspace and say cat in make, and we see the machine compile. I'm going to have in this window a place when I'm going to run raw score, a window when I'm going to run the turtle sim, and here's where I'm going to run these machines. Now before I run them, I remember I need to copy, right, the compile machine, so I have to go into the bell, alright, into lib, and I have the result of this compilation in lib turtle suspend resume. Well, let's copy lib turtle suspend resume into the directory created for the machine by the script, and remember we take away the lib part. Alright, so now we are ready to observe what happens when we run this machine. Alright, we run raw score, we run the little simulated machine, and then we're going to run our arrangement. I should have it here in the history, right? Or arrangement of the machine that restarts and suspends the machine that controls actually the robot. So we can see here the behavior, and funny enough, the machine actually seems to run for 2 seconds straight and then turn for 2 seconds. So it's a bit different than if we run it on its own. In fact, if I go to this window here, all right, and we can investigate, we can look at Ross topic list, and we know we're printing commands of this kind. So let's echo those. And we echo those. You're going to see that funny enough, a command seems to be posted twice. Alright, you see, for example, that you can see 2 times -2 for the Z. What's happening? The machine that controls the other machine suspends it, waits for a second, and restarts it. In fact, it resumes it. So we go back to the same state. So if I look at the documentation on, alright, the original machine, the Ross blind turtle bot machine, the one that is being suspended and resumed, it turns out that if in the state of straight it gets suspended, it goes to a state we don't see here called suspended, but when the resume happens, we go back to straight, and therefore we go back from a different state, and therefore the on entry gets executed again. Then the machine comes here to turn right, it gets suspended, and it moves to a virtual suspended state we don't see here. Then on the resume we come back in, the on entry gets executed again. So that's why we're seeing the effect of 2 commands to go straight and 2 commands to go and turn, and the behavior seems to be different than here. So we're going to stop this machine. Alright, sometimes you're going to have to, you see here the machine running, and this is an old version of CLFSM. If I do Control C, it doesn't seem to respond. So we do a PS -X, and we do a kill of CLFSM, and that stops the execution of CLFSM and the machines. So now we're going to show a fix to the previous situation. So we're going to modify the machine. Actually, the machine is already provided for you in the source code, in which in the suspend state, we're actually going to stop the robot. So when this machine gets suspended, it will stop the turtle sim walking because we put the values to 0. I'm going to show you the machine using a simple editor of logic label finite state machines that runs simply by having Java installed. So it runs on Linux, Mac OS, Windows, etc. So this allows you to edit a finite state machine. It probably doesn't have all the functionalities that you would like, But it allows you to, for example, at the moment we're going to look at the next machine that and as you can see, it's inside the directory machine of the package. Here is the initial state. It always opens on the initial state. It tells you what is the suspend state. It already has that, and the name of the machine. So you can see, expand this area a bit, and you can see that the initial state corresponds to the initial state here in the drawing. So let's have a look at the suspended state. So if we go back here, you change states by selecting what state you want to do, and we see here that this corresponds to the suspended state here. So we will now going to execute this machine to see the difference it makes in the behavior. We saw they have this phenomena of twice in a row we get the command to move the robot, and so despite we suspend the machine seems to move the turtle twice, different of what we see if I start ROSCORE and I start the simulator. Alright, we see the behavior here. And if I start the machine by itself, right, without the master machine, the behavior seems to be these small triangles. I'm going to demonstrate by confirmation that if we run it with the behavior like this, and it is the same machine, but now we're going to stop it at started, we get this phenomena in which you're going to see that it goes twice long, spins for twice as long, and then again travels for twice as long. So let's try to fix that. The way we create machines in our packages is to go to the source part of the package and create the machine. We can actually create it the same way as we created the previous one, and then we put it here. Now we're gonna change the name of the machine, so we're gonna delete this name, and if I go back to the window where our downloads are and our source 2, the machine we're gonna try to run is this guy here. So I'm creating the package for it. Once the package is there, we're gonna go into the package, and I'm doing all the process of building a machine. So we create a subdirectory machine. Again, the code provided for you already comes as a package. We want to reproduce this, so I usually create a tar. This is again very similar to what it happens when we move code into a robot. Here now I move from my downloads area, from the code for this lab, from ROS blind turtle with suspend machine ROS blind turtle dot tar, and we have it here. You can copy ROS blind turtle bot. Alright, that's his directory machine, then the machine setup script, and then the machine setup script of the corresponding machine is not ready yet. I need to untar it. Then just for discipline, I remove the tar. This is because if I modify the source of the machine, I don't want to accidentally extract an older source. We build the suggested. Now, again, I have the discipline of copying the dependencies in the file from the file I'm going to replace. The suggested is going to replace the file, but this section of the suggested make list needs to use the one that has the dependencies that when we create a package, and then I'm ready to copy the suggested into the actual CMake list file. So now we can go up to our workspace and say cat make to compile this machine. Okay, so we finished the compilation and let's see what happens. So here we have the folder created by the script and the library that results of the compile machine. So remember, the library has to be copied into the folder under the Linux part, but the library, for technical reasons of CLFSM, of this version of CLFSM, is like this. So now we run ROScore, we run the little robot, and we're gonna run this machine that is supposed to suspend and restart this machine. So you see both initial state, and apparently we have fixed the problem because this moves just for 1 second. But if you could also inspect here, you see that the only machine that's running is machine 1 and is jumping between state 2 and 3. So really it's not being suspended. So what's going on? The problem? Well, the problem is that this is the name used by the machine that suspends and resumes another machine. And when we ran it, all right, we are actually calling it with another machine here. Okay, so we need to edit the machine so that it has this name. So remember, we have an editor here in my other window. So what we need to, the machine we want to open, yes, I downloaded it from here, but it's the machine that suspends and resumes. Okay, it's in machine, and this is the actual machine we can edit this way. And in its initial state, all right, we need to, this machine was built with another tool, so it has an initial pseudo state. We need to change the name to the name that we have here. So the name that we have here is ROS_blind suspend. So I'm gonna edit that here. And file, save the state. There's another state we would need to make this correction, is the restart state. All right, so we go to the editor, we go to states, go to the restart state. Okay, it double asks me to, and we gonna go here and place that, and I'm gonna save, and I'm gonna exit this. So we need to rebuild this machine. So remember, we modified it in our source code, so we're gonna do a little bit of the process again. Go to, this is the machine we just edited. The machine is actually in the machine directory, and we use the editor to modify this. We can double check this because we can go into turtle machine, state, initial, on entry, and check that's precisely what we did. All right, and you can see also that there was a state called restart, and then on the on entry of this state we have done that change as well. So you can do it with a editor, plain BI editor. So what do? We tar the code. So we're gonna create another time the tar, so you see that this is the, and then I'm gonna move it to its package. So in order to do this, I'm gonna open another uh, tab so I can work with the source here. So the package is here, the machine is here, but now this is an old machine, so I'm gonna move from downloads source to turtle resume machine, the tar I just created. Look that I use move so I also don't get confused that I'm bringing new code. Then I extract it, and then as I said, as per routine, I remove it. In theory, I don't need to change the suggested or anything like that, but I do need to run the setup so the actual files end up where they should be. So the setup modifies what are the includes and so on. So I change to the tab where I'm at the root of my workspace, and I can verify here things have been recompiled. When things are recompiled, we go back here and I have my machine. So the copy now is a little bit easier because I'm copying the lib turtle resume lib into its place in Linux, and now we have the old one there, so I just have to override it. So let's see what happens now. I run raw score, I run the simulator, and now here we run CLFSM with the updated controller and the one that stops. So in our previous attempt, our machine hang. Why would it hang here? Well, because actually we also didn't change this. So the controller machine is waiting for a machine to give us the signal that it's suspended, but it is not. So that machine is not running at all. So we have to edit the machine again, and I'm going to do that again, going to use my Java editor. I'm going to open again from downloads, source, the controller machine, and package. The actual machine is inside the machine subdirectory, and we need to go to the state initial. Okay, and if you see the diagram, it's a transition going from initial to verified that I need to fix. So we are running the editor here. So I look at transitions. There's a transition there with this name. That's the one I want to edit. And remember that the name we want to give is the name of this other machine. We have it over here. So the machine that we need to check if it's suspended is this one. So we can go here and edit the transition. So let's save the state. Even when I change to the next state, verify. Okay, I'm asked to change the state. Let's look at transitions. This is the transition I want to edit. I want to edit this part. Okay, I save the state. All right, there's another transition here that requires that. It's coming out of restart. So let's go to the state restart. Okay, in the state restart, let's look at the transition. That's the transition I want to edit. I want to edit it to, I need to get rid of this and put the new name. And then others we want to is the one going out of let it run again. So we save the state, we go to the state let run, and here we look at the transitions. This is the transition I want to edit. I want to edit this part and put the new name, save the state, and those are 1, 2, 3, 4 transitions. So we can exit the machine. Again, now we go to where in source we have that machine. So what we have done is edit parts of this machine. You can again look at the files in there, and you can see that transitions finish in expression. So I can look at all of the ones that finish in expr. They are those. And actually, I can use a plain editor also to inspect them. This is a transition that has just true. And we can check that I didn't do a mistake with the editor. This is just for my own. So finish and suspend. The next one. All right, ROS all the way to suspend. The next one is this one here. All right. And the last one seems correct as well. So remember, I have in the history here my tar, so I can do that. Now I can go here and go to my machine subdirectory. I should have the move in my history. I should have the tar that extracts. I should have the remove that does that. And I should also run, because I modified the code, the setup. Once I do that, we compile again. The machine gets compiled. We go here toward the bell. Remember, I have the copy of the library just recently compiled. And now we're going to repeat the execution. We start ROS core. We start the simulator, the turtle, and we're going to start the machines with a new controller. And we say there that stops, moves it, stops, moves it, stops. All right, and if we go back here, we go back to our ROS topic list, all right, and then ROS topic echo, and the command velocity. We see the stop in between the two, and it has this particular effect. We're going to build a little bit more sophisticated software architecture with ROS, so that the machine that suspends or resumes a machine consults somewhere else by using a client service whether it should allow this machine to run or should suspend it. That is going to be a service, and we're going to give you a little package where that service listens to a topic, which then it tells it whether to stop or not. So that code is also provided for you in the packages. And so that is what we call the status report package. And in this case, I'm just going to tar it completely. So tar status report dot tar, and I'm going to have to create it there. So minus create and the name of that, and it gets created there. and I'm gonna put it in where we have been constructing things that we saw just recently. I'll make it smaller again. I think we were building things in this one and using the other one for just using the catmake. So I'm gonna move from downloads from the software for the second lab, the status report.tar, putting it here, and I'm gonna extract it here as a full catkin package. Is there, so I remove the tar, and as I said, I'm using the other for compilation, so I just need to say catkin make, and this particular little package gets compiled, and we're going to try to demonstrate how it works. So you can see there, obviously went through everything that we have now in our workspace to compile. Let me just exit. This is the place where we run things in lib. After compilation, this package status report, if you look at it, actually produces two executables. One of them is something that I did to check that this guy is doing its job. So actually I'm gonna change there, and I'm gonna open another tab from here. So we have the two programs that you see here, so I'm gonna run them simultaneously. Obviously we need the middleware, so I'll restart ROScore, and here I'm gonna just start the program that offers the service to the state machine, and I'm gonna offer here the run the test node. Okay, so you can see that at the moment this test node is actually questioning the service. What is the status? And the status is to continue. The service is responding 0 to every query. So this logging or display is every time I can show you that if I stop the test, then I don't get any more output here. If I start the test is a program that uses the service as well. So we see that every time we respond to a request, we produce some output here. And let me just go through some of the things that we can use ROS topic list to see that now we have a status. We can then get ROS topic info to find more about this, and the type is a message of type string. It turns out that if we publish the message of type string and actually the string stop, the status changes. So now this thing has changed the status to stop, and therefore the program that queries now finds out the status being stopped. You had to kill the ROS topics call, but if I put run, now we're gonna see that in the program it has heard run, so now puts continue, and anybody who queries this status finds out that we should continue running. So this is a little tool to enable the state machine to query. So the state machine is going to play the role of this tester while the status is running. So now we are ready to start compiling and running this machine. Now remember that the documentation of the lab calls ROS blind turtle bot, and we need to edit that. Or maybe you want to edit the ROS blind turtle bot and have a suspended state. For illustration here, I'm gonna again just run the editor. I'm gonna go and open from in downloads on source 2 is where I have the now turtle suspend on topic package. In the folder machine, I actually have the machine. So I open that, and the first state that I would like to fix is the state suspend child. So I go here and I choose the state suspend child, and that's the name that I want to modify. Remember here in my history, I have what the machine should be called. It should be called ROS blind turtle suspended. So I'm copying that and I'm replacing it here, and I save the state. Another state that needs change for that would be the same state has a transition going out with that name. So I'm not going to make the situation as I'm going to look at transitions. Actually, there's several transitions here, as you can see. There's two going out. Actually, the first one is the one I'm interested. So that's the one we choose. We say OK. And what we want to do is edit this little bit apart. Actually, I need to take the T that's there and place that new transition there. And now I save the state. So we're done with that state here. So this is just shall I stop after. So but the next state, verify, check whether that machine is suspended. So we're gonna go and fix the state. I don't know the transition, but we go to the state verify. Okay, and that state has a transition, has several transitions, but this is the one we're interested in editing. So we click OK to open these widget to edit the name of the machine and put the new name there and save that. So this state is done. The state restart suffers for both things, the name in the state and the name in the transition. So we need to fix that state as well. The state is called restart. So let's go to state restart. Okay. And here from the T to the R, we delete and we place the new name. And also the transition, there's a transition there. This one we want to edit. Again, from the T to the R, we replace the name. All right, warn us that we should save the state or nothing happens. There is that let run has also a transition where the machine name or which machine we stop needs to be edited. It's called let run. So I go to the editor, I go to the state let run. Okay, there's a transition, this one here that we need to edit. And again, from bot to Ross, we put the name of the same machine. So save that and exit the machine. I don't see at the moment any other place where that name occurs. You can do the trick of looking at the old name, which was Rose Blind Turtle, and we can actually do the trick of going here and grab that name in Turtle Resume on topic. In the folder machine is the machine, and actually going to grab everywhere, and we're going to check that all the names there in all states or transitions have been replaced. So we have to go on to on topic machine, and I do the same trick again, tar the machine. You may want to not do this step and work directly here in your workspace. So now we need to create the package. Remember, the instructions here will tell us that the package is created a little bit different because now we depend on this machine depends on status report. So we're gonna create the package slightly different. Again, an illustration of a machine that depends on something a bit more complicated. So the package here now for on topic is a bit more complicated. So we're gonna go to that machine, and there's nothing there, so we do for the very first time the machine folder. I move into the machine folder, and I'm gonna move from downloads, source to turtle on topic machine, turtle on topic, the tar file. Once you move it here, maybe you are happier editing here the machine rather than editing in where it came from and keeping 2 copies of it as I've been doing. Up to you. I prefer to keep a kind of an executable area of my machines, so it's here. The machine, now remember, we go to one of our previously run, maybe the very first machine, and bring the machine setup script here. We do the machine of the, we do the setup of this machine. Okay, and remember that because it's the very first time, we want to inspect the dependencies made in the, and you see here that there's a dependency when we created the package. So this is a machine that depends on things beyond CLFSM and leave CLFSM. So the suggested CMake list file needs this update of this little part before the suggested replaces the actual CMake list file. So we're ready to compile this machine. So we just say, I have this place where I compile them. And remember, here is a place where I run them. So I'm going to go just one level up. In anticipation, my script created this folder, things are compiling. It's good to remember to stop ROScore because ROScore consumes a lot of resources while you're trying to compile. So now if we go back here to the, we have the, as I mentioned, the place where we're going to place the library, and probably was still linking, so maybe we need to go again. There is the library we need, is the compilation of the machine. So we're going to copy that file across the directory of the machine with Linux, and then the library itself, but without the prefix lib. So let's see how this works now, because we can start ROScore. We can start the turtle sim. We're just going to move it here. Now remember, the machine needs a service, in a sense needs, so instead of the machine doesn't run the client, we need to move the status report node. At the moment, nobody's doing queries. And now, yes, CLFSM, just verbose. Now, turtle suspend, no on topic. All right, and the ROS run turtle bot with suspend. And so here they go. And we see the machine going. Now, remember that here, if we publish stop, things have stopped. We stop the ROS topic. We publish run. You can see here that there was a change to stop. And this is the responses being sent to the machine, who's constantly querying, is it time to resume? So now if I say run, the status changes to run. The machine knows it's time to run. Okay, so this is an arrangement of machines where the super machine is being controlled by ROS topics published from here. So you can have another machine control the machine that controls the machine. So you can make a hierarchy of things. So let's just demonstrate that again. If I publish in that topic this stop, then with a bit of a traditional ROS delay, we get this result that the behavior gets suspended at the control of the super machine here.